Hi students, welcome to the fifth lecture in permutations and combinations. I hope you have watched the previous 4 lectures. If not, go back and watch those 4 lectures and then only come to fifth lecture. Anyway, I'm recalling what we have done in the first 4 lectures. So in the first 4 lectures we have defined the fundamental principle of counting. So both multiplication and addition. So if a task T can be divided into two works W1 and W2, then the number of ways of doing the task is equal to number of ways of doing W1 times number of ways of doing W2. So here we are going to perform W1 and W2, and the number of ways of doing W1 is denoted by M. Number of ways of W2 is N. If W1 can be performed in M ways and W2 can be performed in N ways, then the number of ways of completing the task is equal to number of ways of completing W1 times number of ways of completing W2. And the second one is if a task can be performed in two formats, W1 or W2, and W1 can be performed in M ways and W2 can be performed in N ways, then the number of ways of completing the task is equal to number of ways of completing W1 plus number of ways of completing W2. So the first thing that you have to remember here is whenever end comes, you have a product. Whenever R comes, you have sum. So this is the basic principle that you have to remember throughout this chapter. And next we have defined factorials. Factorials are generally defined for non-negative integers. If n is a positive integer, we can define n factorial as n times n minus 1 factorial. And 0 factorial is defined to be 1 by convention. So if you want 5 factorial is equal to 5 times 4 factorial, or else which we can write it as 5 times 4 times 3 times 2 times 1. So we have to start with the positive integer that they have given, and then we have to keep on decreasing until we hit 1. So this is the notation for factorial, or this is the meaning of factorial. And then we have defined linear permutations and circular permutations. Linear permutation means we will arrange things in a row. Circular permutation means we will arrange things in a circle. So the basic difference between linear permutation and circular permutation is, in a linear permutation we have first place, second place and so on up to last place. But in a circular permutation we don't have the notion of first place, second place and so on. We can define the position of an object in circular permutation with respect to a particular element. But whereas in a linear permutation we can define the position without the help of the remaining elements. Irrespective of the remaining elements, we can directly define the position. For example, if you take this one, A, B, C, D. So if you take A, B, C, D, B is in the second position. But if you consider this circular permutation, this is A, B, C and D. I cannot say that B is in the second position, and I cannot say that A is in the first position, nor I cannot say that D is in the last position. Whereas in a linear permutation, I can say that A is in the first position, B second, C third and D last. But here what I can say is B is to the right of A, or A is to the left side of B. Left side of B means in the anti-clockwise direction. B is to the right of A in the sense B is located to the clockwise direction of A. So these are the basic differences between linear permutations and circular permutations. The main motto in this chapter is to count the number of linear permutations. And the number of linear permutations is in general denoted by NPR. So NPR means number of permutations of n distinct objects taken R at a time. And the number of permutations of n distinct objects taken R at a time is given by n times n minus 1 times n minus 2, so on up to n minus R plus 1. Or else we can give a formula for this one, which we can write it as n factorial upon n minus R factorial. Therefore NPR is equal to n factorial upon n minus R factorial. So the number of permutations of n distinct objects taken R at a time is equal to n factorial upon n minus R factorial. and we have seen few results based on this one. So NPR is equal to n times n minus 1 PR minus 1. So we have given two proofs for this one. The first one is based on the formula and the second one is based on a combinatorial argument. Okay, and then we have seen this one, NPR is equal to n minus 1 PR plus R times n minus 1 PR minus 1. So here R times n minus 1 PR minus 1, this term stands for the number of permutations of n distinct objects taken R at a time, which always contain a particular element. And here NPR stands for number of permutations of n distinct objects taken R at a time. This n minus 1 PR stands for number of permutations of n minus 1 distinct objects taken R at a time. Or else we can read this n minus 1 PR differently. If you read this one a little bit differently, we'll have number of permutations of n distinct objects taken R at a time without containing a particular element. Therefore, the total number of permutations is equal to number of permutations without containing a particular element plus number of permutations which always contain a particular element. And then we have seen few problems related to the formula of NPR, and then we have discussed few problems related to permutations. So in all those problems, what we have to do is we have to first fix the constraint and then we have to fill the remaining places. So this is what we have learnt in the first 4 lectures. Now in this lecture we will do a few more problems related to permutations, and the first problem is like this. Find the number of 4-digit numbers that can be formed using the digits 2, 3, 5, 6, 8 without repetition. How many of these numbers are divisible by 2? How many of these numbers are divisible by 3? How many of these numbers are divisible by 4? How many of these numbers are divisible by 5? How many of these numbers are divisible by 25? So first of all, let us write down what are the numbers that they have given. So the numbers that they have given are 2, 3, 5, 6, 8. So on the whole they have given 5 numbers or 5 objects. Now the first question is how many 4-digit numbers that we can form. Number of 4-digit numbers is equal to 5p4. So why the answer is 5p4? Because we have to fill these 4 blanks. We have to fill these 4 blanks using these 5 objects. So we have 5 objects and we have 4 blanks, and the number of ways of filling these 4 blanks using these 5 objects is 5p4. So which is equal to 5 factorial upon 5 minus 4 factorial, which is equal to 5 factorial upon 1 factorial, which is equal to 120. So the total number of 4-digit numbers that we can form using the digits 2, 3, 5, 6, 8 is 120. Now the first question is how many of these numbers are divisible by 2? So the first one is how many are divisible by 2? So we have 5 different questions. So how many are divisible by 2, how many are divisible by 3, how many are divisible by 4, how many are divisible by 5, and how many are divisible by 25. So for this you should know the test of divisibility of all these numbers. So when do you say that a number is divisible by 2? We say that the number is divisible by 2 if the units place is either 0, 2 or 4 or 6 or 8. Or else we can directly say that if the number is an even number, I can say that the number is divisible by 2. When do you say that the number is an even number? The units place must be either 0 or 2 or 4 or 6 or 8. Now coming to this one, test of divisibility of 3. So when do you say that a number is divisible by 3? If the sum of all the digits in the number is divisible by 3, then we say that the number is divisible by 3. Next, 4. So when do you say that a number is divisible by 4? If the last 2 digits are divisible by 4, then we say that the number is divisible by 4. Next, 5. If the units place is either 0 or 5, then we say that the number is divisible by 5. Next we have 25. So when do you say that the number is divisible by 25? If the last two numbers are are 0 0 or 2 5 or 5 0 or 7 5, then we say that the number is divisible by 25. Or else we can say that if the last two numbers are divisible by 25, then we can say that the number is divisible by 25. Okay, so these are the test of divisibilities that we should know before answering this question. So first let us answer the first question. How many of these numbers are divisible by 2? So the numbers that we have are 2, 3, 5, 6, 8. So we have to form 4-digit numbers, and out of these, we have to count how many 4-digit numbers that we can form using these digits which are divisible by 2. So here we have to fill the last place by either 2 or 6 or 8, because these are the only even numbers that are there in our list. In our list, the even numbers are 2, 6 and 8. That means that we have to fill the last place with either 2 or 6 or 8. Now we have to fill these 4 blanks, 1, 2, 3 and 4. So I can fill the last blank with either 2 or 6 or 8. So I can fill this blank in 3 ways. W1 is to fill the last blank. W2 is to fill the remaining 3 blanks. Now the number of ways of doing W1 is equal to 3. Number of ways of doing W2. After filling the last blank with one of these objects, how many objects are left? How many objects are left with us? So there will be 4 more objects, and we have to fill these 3 blanks. Therefore, number of ways of filling these 3 blanks with 4 objects is equal to 4p3. Therefore, the total number of ways of completing the task is equal to number of ways of doing W1 times number of ways of doing W2, which is equal to 3 times 4p3. So you can leave the result as it is. So these are the total number of 4-digit numbers that can be formed using 2, 3, 5, 6, 8, which are divisible by 2. Next, divisible by 3. So we have to count how many 4-digit numbers are divisible by 3. The given digits are 2, 3, 5, 6 and 8. So they have given 5 digits. We have to form 4-digit numbers, and we have to form those 4-digit numbers which are divisible by 3. So we know that the test of divisibility of 3 is the sum should be divisible by 3. We have to select 4 numbers. Which 4 numbers we have to select is the question. So we have to select those 4 numbers whose sum is divisible by 3. Okay. So first let us look at the sum of these 5 digits. Okay. So selecting 4 digits out of 5 digits is same as removing 1 digit. Suppose there are 5 people in your class. I have to select 4 people. So selecting 4 people is same as removing 1 person. Okay. So instead of selecting 4 numbers, I can just remove 1 number. Okay. Here we have to select 4 numbers. So which 4 numbers we have to select is the question. So first let us look at the sum of the given digits. First, the sum of given digits is equal to 2 plus 3 plus 5 plus 6 plus 8, which is equal to 2 plus 3 is 5 plus 5 is 10, 10 plus 6 is 16 plus 8, 24. 24 is divisible by 3. But here we are not supposed to take all the 5 numbers. We are supposed to take only 4 numbers. Okay. So selecting 4 numbers is same as removing 1 number. If I remove 2 from the list, so the sum will be 24 minus 2, which is equal to 22, which is not divisible by 3. So I should not remove 2. If I remove 3, so 24 minus 3, which is equal to 21, which is divisible by 3. Therefore, I can remove this 3. Next 5. 24 minus 5 is 19, which is not divisible by 3. So I cannot remove 5. Now 6. 24 minus 6, which is 18, which is divisible by 3. So I can remove 6. Next 8. 24 minus 8, which is 16, which is not divisible by 3. So I can remove 3 and I can remove 6. So if I remove 3, what are the numbers I have? 2, 3. Sorry, I am removing 3, so I will not have 3. So 2, 5, 6, 8. Or I will have 2, 3, 5, 8. I can have 4-digit numbers using these 4 digits, or I can have 4-digit numbers using these 4 digits. So the number of 4-digit numbers that can be formed using these 4 digits is, number of 4-digit numbers is equal to 4 factorial. So here I can form any 4-digit numbers using these 4 digits, 2, 5, 6, 8. Any 4-digit number formed using these 4 digits is going to be divisible by 3. Therefore, the total number of 4-digit numbers using these using these 4 digits is 4 factorial. And similarly, using these 4 digits is going to be 4 factorial. So the total is equal to 4 factorial plus 4 factorial, or 2 times 4 factorial. So these are the total number of 4-digit numbers that are divisible by 3. So let me explain the question one more time. So this is little bit complicated. This is not as trivial as the case of divisibility by 2. So here the question is divisibility by 3. So we have these 5 numbers, 2, 3, 5, 6, 8. We have to form 4-digit numbers which are divisible by 3. So in order to form a 4-digit number using these 5 digits, I have to remove 1 digit, or else I have to select 4 digits. Selecting 4 digits out of 5 digits is same as removing 1 digit. So which digit we have to remove, that is the question. So before removing one of the digits, first let us look at the sum of the given digits. Sum of the given digits is 24, which is divisible by 3. Okay. So if the sum of the 4 digits is not divisible by 3 also, then nothing will happen. So what you have to do is, what happens if you remove 2? So if you remove 2, so from the sum we have to remove 2. So 24 minus 2, which is equal to 22. So 22 is not divisible by 3. So removing 2 is not a correct option. Okay. So if I remove 3, then 24 minus 3 is 21, which is divisible by 3. So I can remove 3. So this is one option. If I remove 5, then it is not going to be divisible by 3. If I remove 6, then it is going to be divisible by 3. If I remove 8, then it is not going to be divisible by 3. So the only options that we have is I can remove either 3 or I can remove either 6. If I remove 3, then what are the numbers that we have? We have the numbers 2, 5, 6, 8. If I remove 6, we have the numbers 2, 3, 5, 8. So I can form any 4-digit numbers using these 4 digits. I can form any 4-digit number using these 4 digits. All the 4-digit numbers that are formed using these 4 digits are divisible by 3. All the 4-digit numbers that are formed using these 4 digits are divisible by 3. Therefore, the total number of 4-digit numbers which are divisible by 3 is equal to number of 4-digit numbers that are formed using these 4 digits plus number of 4-digit numbers that are formed using these 4 digits. Number of 4-digit numbers that are formed using these 4 digits is 4 factorial, and number of 4-digit numbers that are formed using these 4 digits is 4 factorial. Therefore, the total number of 4-digit numbers that are divisible by 3 is equal to 4 factorial plus 4 factorial, which is 2 times 4. Now let us move on to the next one, that is we have to find how many 4-digit numbers are divisible by 4. Divisible by 4. So the given digits are 2, 3, 5, 6 and 8. So what is the test of divisibility for 4? The test of divisibility for 4 is the last 2 digits must be divisible by 4. So here what we have to do is we have to form 4-digit numbers. We have to form 4-digit numbers which are divisible by 4. So 4-digit numbers 1, 2, 3 and 4. So now we cannot fill the last 2 places arbitrarily. We have to fill with those digits which are divisible by 4. So the options that we have here are 28. 28 is one option. I can fill with 32 and then I can fill with 36, 52 and then 56, 64, 68 and then 70s we don't have anything, 82, 86, no. So these are the only options that we have. I can fill the last 2 digits with one of these options. So how many different options we have? 1, 2, 3, 4, 5, 6. So we have 6 different options to fill the last 2 blanks. So we can divide this task into 2 parts. W1 is to fill the last 2 places and W2 is to fill the remaining 2 places. So the number of ways of doing W1 here is equal to 6. Now number of ways of doing W2. After filling the last 2 places with 2 digits, we will be left with 3 digits. So the total number of digits is 5. So we are filling the last 2 digits with one of these 2 digits. Therefore, the number of digits that are left is 3. Therefore, the total number of ways of doing W2 is equal to 3p2. So this implies the total number of ways of completing the task is equal to 6 times 3p2. So these are the total number of 4-digit numbers that we can form using the given digits 2, 3, 5, 6, 8 which are divisible by 4. So I encourage the students to write down the final statement. The final statement is there are 6 times 3p2 4-digit numbers which are divisible by 4. Next, divisible by 5. So we know the test of divisibility for 5. What is the test of divisibility for 5? The test of divisibility for 5 is the last digit must be either 0 or 5. So here the given digits are 2, 3, 5, 6, 8. So we have to form 4-digit numbers 1, 2, 3, 4. I have to fill the last digit with either 0 or 5. So we don't have 0 here in this collection, therefore I can fill the last digit only with 5. W1 is to fill the last digit with 5. So the number of ways of doing W1 is equal to 1. And after filling the last place with 5, we will be left with 3 blanks. I can fill these 3 blanks with any of these 4 objects. So we can have 2, 3, 6, 8. I can fill these 3 blanks using these 4 digits. This one I can do it in 4p3 ways. Therefore, the total number of ways of completing the task is equal to number of ways of completing W1 times number of ways of completing W2, which is equal to 1 times 4p3. So these are the total number of 4-digit numbers that are formed using the digits 2, 3, 5, 6, 8, which are divisible by 5. Now let us move on to the last one, divisible by 25. So when do you say that a number is divisible by 25? The last position must be either 0, 0 or 2, 5 or 5, 0 or 7, 5. So here we have to form 4-digit numbers which are divisible by 25. So I cannot fill the last 2 digits with 0, 0 because 0 is not there in the collection. And I cannot fill with 5, 0 because 0 is not there in the collection, and 7, 5 is also not there in the collection because 7 is not there. So the only option here is I can fill the last 2 digits with 2 and 5. So W1 is to fill the last 2 digits with 2 and 5. Or else we can say that the W1 is to fill the third place with 2 and the fourth place with 5. And coming to W2, I can fill these 2 objects or 2 places with any of the remaining objects. After removing 2 and 5, what are the objects that we have? 3, 6, 8. I can fill these 2 places with any of these 3 objects. So this one I can do it in 3p2 ways. So W2 can be done in 3p2 ways, W1 can be done in only one way. Therefore, the total number of ways of completing the task is equal to number of ways of completing W1 times number of ways of completing W2, which is equal to 1 times 3p2. So there are 3p2 number of 4-digit numbers that are formed using the digits 2, 3, 5, 6, 8, which are divisible by 25. I repeat, there are 3p2 number of 4-digit numbers which are formed using the digits 2, 3, 5, 6, 8, which are divisible by 25. So this is all about the divisibility problems. So here the important thing that you have to note is divisible by 3 and divisible by 4. First, let us answer these 2 questions quickly. Find the number of 4-digit numbers that can be formed using the digits 1, 2, 3, 4, 5. The next question is find the number of 4-digit numbers that can be formed using the digits 0, 1, 2, 3, 4. So in both the questions, if you observe, the number of digits that they have given is 5. So here the digits are 1, 2, 3, 4, 5. We have 5 letters or 5 digits. Now here in this case we have 0, 1, 2, 3, 4. So here also we have 5 digits. In both these questions, our motto is to find the number of 4-digit numbers. So the number of 4-digit numbers here is equal to 5p4 because we have 5 objects and we have to fill 4 blanks. 5 objects and 1, 2, 3, 4. these 4 blanks should be filled with these 5 objects. The number of ways of filling these 4 blanks using these 5 objects is 5p4. Therefore, the number of 4-digit numbers is equal to 5p4. Okay. So here the number of 4-digit numbers is equal to here also you can give the answer as 5p4, but this is not the actual answer. So why this is not the actual answer means we have this culprit 0. So why I am calling 0 as the culprit means, so if you take this number 1 2 3 0, so this is a 4-digit number. But 0 1 2 3, it is not a 4-digit number. So here, if you want to obtain the correct answer, what you have to do is we have to remove all those numbers which start with 0. So how many numbers are there which start with 0? So we have to fill the first blank with 0. 1 2 3 4. We have to fill the first blank with 0. After filling the first blank with 0, we will be left with 3 blanks and 4 numbers. What are the 4 numbers we have? 1 2 3 4. So I can fill these 3 blanks using these 4 digits in 4p3 ways. Therefore, the total number of 4-digit numbers is going to be 5p4 minus 4p3. So why we have this 4p3 means we have 4p3 numbers which start with 0. So if a 4-digit number starts with 0, it is not called as a 4-digit number. It will be called as a 3-digit number. So this is the difference between these two questions. So whenever 0 comes, you have to be little bit careful. With 0, you cannot start a number. So you have to remove all those numbers which start with 0. There are 4p3 numbers which start with 0. So all these numbers will not be considered as 4-digit numbers. These numbers will be considered as 3-digit numbers. Therefore, the total number of 4-digit numbers is going to be 5p4 minus 4p3. Okay. Next, we have an interesting question. Find the sum of all 4-digit numbers that can be formed using the digits 1, 3, 5, 7, 9. I repeat, find the sum of all 4-digit numbers that can be formed using the digits 1, 3, 5, 7, 9. So they have given 5 digits. What are those 5 digits? 1, 3, 5, 7 and 9. So how many 4-digit numbers we can have? 4-digit numbers is equal to 5p4, which is equal to 5 factorial upon 1 factorial, which is 120. So we can have 120 4-digit numbers that can be formed using the digits 1, 3, 5, 7, 9. Now what is the question? The question is we have to find the sum of all these 120 numbers. Listing down all these 120 numbers is itself a laborious process. After listing down all these 120 numbers, what we have to do is we have to count all these numbers. All this means we have to find the sum of all these 120 numbers. So I cannot start listing down all these 120 numbers. We have to find a technique. So for this, first let us try to understand the sum of 2 digits or the sum of 2 numbers. If I ask you to find the sum of these numbers, find the sum of 23 and 54. So what you will do here, you will write it as 23 here and then 54. and then what you will do is 3 plus 4 is 7 and 2 plus 5 is 7. So the answer is 77. Okay, so let us try to understand it carefully. So we have 23. So in this 23 I can write it as 2 times 10 plus 3 times 1. And then 54 I can write it as 5 times 10 plus 4 times 1. So total how many units are there in each number? In this number we have 3 units, and in this number we have 4 units. So if I add, what happens? I will have 7 tenths plus 7 ones. 7 tenths plus 7 ones is nothing but 77. Okay. So similarly, if I ask you to find out the sum of 3-digit number, or if I give you one more example, 1, 2, 3, 4, 5, 6. So this 1, 2, 3 I can write it as 1 hundreds plus 2 tenths plus 3 ones. And then 4, 5, 6. 4, 5, 6 I can write it as 4 hundreds, 5 tenths plus 6 ones. So on the whole, how many ones we have? 3 plus 6, 9 ones. And how many tenths we have? 2 plus 5, 7 tenths. And how many hundreds we have? 5 hundreds. Therefore the sum is going to be 570. 3 plus 9, 579. So here also if you add, we will get the same number. 9, 7, 5. So these things will help us to find out the sum of these 120 numbers. So the first thing that I have to do is I have to list down all these 120 numbers. After listing down all these 120 numbers, what I have to do is I have to count the units place, and then I have to count the tens place, and then I have to count the hundreds place, and then I have to count the thousands place. So first let us try to write down all these 120 numbers. Okay, so here I have listed down all these 120 numbers. So I will explain how I have listed down all these 120 numbers. So how many numbers are there which end with 1? So the given digits are 1, 3, 5, 7 and 9. Now I want to find out how many 4-digit numbers are there which end with 1. I have filled the last blank with 1. After filling the last blank with 1, I will be left with these 3 blanks. And what are the objects that I am left with? 3, 5, 7, 9. I am left with 4 objects, and I have to fill these 3 places. In how many ways I can fill these 4 objects in these 3 places? The number of ways is going to be 4p3. So on the whole, there are 4p3 numbers which end with 1. So here are the 4p3 numbers which are going to end with 1. Similarly, here also I have 4p3 numbers which end with 3. So here also I have 4p3 numbers which end with 5. Here I have 4p3 numbers which end with 7. Here I have 4p3 numbers which end with 9. So let me see whether I have listed down all the 120 numbers or not. So we have 5 times 4p3. 5 times 4p3 is nothing but 5p4, which is equal to 5 factorial, which is equal to 120. So why 5 times 4p3 is equal to 5p4? N times n minus 1 pr minus 1 is equal to npr. Okay, so here are my 120 numbers. Now I have to count all the units placed in these 120 numbers. Now what is the sum of all units placed in these 120 numbers? Now the sum of all units placed is equal to sum of all units placed is equal to, I have 4p3 times 1 plus I have 4p3 times 3, I have 4p3 times 5 plus I have 4p3 times 7 plus I have 4p3 times 9, which I can write it as 4p3 times 1 plus 3 plus 5 plus 7 plus 9. So this is the sum of all units placed. Now I have calculated the sum of all the units placed in all these 120 numbers. I have calculated the sum of all the units placed in all these 120 numbers. Our next target is to find the sum of all tens places. So for this, what I am doing is I am rearranging these 120 numbers. I am rearranging these 120 numbers. So by rearrangement, I am not going to change the sum. So if I ask you to find out this 1 plus 3 plus 4 plus 9. 1 plus 3 plus 4 plus 9 is same as 4 plus 3 plus 9 plus 1. So here what I am doing is I am just rearranging the terms. By rearranging the terms, I am not going to change the sum. As long as I don't add any number or as long as I don't delete any number, by just rearrangement, I am not going to change the sum. So here what I am doing is I am just rearranging these numbers. Our next target is to find out the sum of all our next target is to find the sum of all tens place. Sum of all digits in the tens place. So for this, I am rearranging the terms like this. So how many numbers are there in which 1 comes in the tens place? How many numbers are there in which 1 comes in the tens place? So the given digits are 1, 3, 5, 7, 9. I want 1 in the tens place. So I'll be left with only 3 blanks. And I will be left with 4 numbers without 1. 3, 5, 7, 9. Now I have to fill these 3 blanks using those 4 numbers. So which I can do it in 4p3 ways. Similarly, there are 4p3 numbers which end numbers in which 3 comes in the tens place, and 4p3 numbers in which 5 comes in the tens place. There are 4p3 numbers in which 7 comes in the tens place. There are 4p3 numbers in which 9 comes in the tens place. So if I add all these numbers, then I will get the 120 numbers. So I am not adding any number, or I am not writing any number in addition, or I am not adding any, or I am not deleting any number. So the total 120 numbers are there intact. The only thing that I am doing is I am rearranging the terms. By rearrangement, the sum is not going to be disturbed. Now how many tens we have? Number of tens is equal to there are 4p3 into 1 tens plus 4p3 into 3 tens plus so on 4p3 into 9 tens, which is equal to 4p3 times 10 times 1 plus 3 plus 5 plus 7 plus 9. So similarly, I can add the hundreds place and I can add the thousands place. So if I add the hundreds place, then it's going to be then it's going to be 4p3 times 100 times 1 plus 3 plus 5 plus 7 plus 9. So thousands place, which is going to be 4p3 times 1000 times 1 plus 3 plus 5 plus 7 plus 9. Now total is equal to 4p3 times 1000 times 1 plus 3 plus 5 plus 7 plus 9 plus 4p3 times 100 times 1 plus 3 plus 5 plus 7 plus 9 plus 4p3 times 10 times 1 plus 3 plus 5 plus 7 plus 9 plus 4p3 times 1 plus 3 plus 5 plus 7 plus 9, which is equal to 4p3 times 1 plus 3 plus 5 plus 7 plus 9. I can take common times 1000 plus 100 plus 10 plus 1, which I can write it as 4p3. I can write it as 5 minus 1 p 4 minus 1. Why I am writing it as 5 minus 1 p 4 minus 1 means 5 is the number of digits, 4 is the number of 4-digit numbers that we are going to form, times 1 plus 3 plus 5 plus 7 is sum of the given digits. Times 1 1 1 1 4 times. How many ones we have? 4. So if you write it in this way, then we can generalize. So before going into the generalization, this is the sum of the 120 numbers that we can form using the numbers 1 3 5 7 9. So if you have any doubt, you can cross verify by writing down all those 120 numbers and adding them together. So now we have, so what we have done is, first we have added the units place, and then we have added the tens place, and then hundreds place, and then thousands place. So if you add all those things, this is the answer that we are going to get. So if you observe carefully, we can generalize this one, and the generalization is like this: the sum of all odd digit numbers that can be formed using the given n non-zero digits is equal to n minus 1 p r minus 1 times sum of the given digits times 1 1 1 1 1 r times. So in the previous problem, n is equal to 5 and r is equal to 4. That's why we have 4p3. 4p3 times sum of the given digits, and finally we have 4 ones because r is equal to 4. So what happens if 0 is there in one of the digits? If 0 is there in one of the digits, then the formula will be modified. So if 0 is there in one of the digits, then we are not going to get the exact r number of digits, r digited numbers. So we'll be removing these numbers. So if you understand the derivation of this formula, then you can easily understand this formula. The sum of all r digited numbers with with n digits. If 0 is included, then this is the formula: n minus 1 p r minus 1 times sum of the given digits times 1 1 1 1 1 r times, minus n minus 2 p r minus 2 times sum of the given digits times 1 1 1 1 1 r minus 2 times. Because here what we are doing is we are adding all those r digited numbers which are starting with 0. R digited number starting with 0 is same as r minus 1 digited numbers. So r digited numbers starting with 0 should be discarded. So if you discard those numbers, this is the sum that we are going to be removing. Okay. Let us answer this small problem. How many 4-digit numbers can be formed using the digits 1, 2, 5, 7, 8, 9? How many of these numbers begin with 9 and end with 2? So the given digits are 1, 2, 5, 7, 8, 9. So how many digits they have given? Total they have given 6 digits. Now we have to form 4-digit numbers. That means we have to fill these 4 blanks. 1, 2, 3, 4. We have to fill these 4 blanks using these 6 digits. Therefore, the number of ways of filling these 4 blanks using these 6 digits is equal to 6p4. Number of 4-digit numbers is equal to 6p4. Now let us move on to this next part in this question. How many of these numbers begin with 9 and end with 2? So begin with 9 and end with 2 means first you have to fill these 2 blanks. The first blank with 9 and the last blank with 2. After filling these 2 blanks, we will be left with these 2. And the digits that we are left with are 1, 5, 7, 8. There are 4 digits which are left over and there are 2 blanks which are left over. I can fill these 2 blanks using these 4 digits in 4p2 ways. So number of 4-digit numbers that begin with 9 and end with 2 is 4p2. So you have to write that entire statement. Number of 4-digit numbers that begin with 9 and end with 2 is equal to 4p2. Here we have a small problem, but it is going to be helpful in finding the number of injections. Okay, so the problem is like this. Find the number of injections from a set A with 5 elements to a set B with 7 elements. So before answering this question, so you should recall what do you mean by an injection. So injection means a function in which no 2 elements in the domain will go to the same output. That means for different inputs we'll have different outputs. If you want to understand it using diagrams, A, B, C, 1, 2, A going to 1, B going to 2 and C is also going to 2. This is not an injection. A, B, C, 1, 2, 3, 4. A is going to 1, B is going to 2 and C is going to 4. So this is an injection. So for different inputs here we have different outputs, whereas here for different inputs we have the same output. B and C are going to the same output. Therefore it is not an injection, and this is an injection. Now here the question is to find the number of injections from a set A with 5 elements to a set B with 7 elements. So we have a set A which has 5 elements A, B, C, D, E, and we have a set B which has 7 elements 1, 2, 3, 4, 5, 6, 7. So for the sake of simplicity, A contains the elements A, B, C, D, E and B contains the elements 1, 2, 3, 4, 5, 6, 7. So already we have addressed this problem. So how we have addressed this problem we will see. So assume that we have 5 different people or 5 people and we have 7 different chairs. Now in how many ways we can arrange these 5 different people in these 7 different chairs? That is the question. So in one chair I cannot accommodate 2 people. So answering the number of injections from A to B is same as answering this question. In how many ways I can arrange these 5 people in 7 different places. So already we have addressed this problem. The number of ways of arranging 5 people in 7 different chairs is going to be 7p5. Therefore the number of injections from a set A with 5 elements to a set B with 7 elements is going to be 7p5. Number of injections is equal to 7p5. Why? Because number of ways of arranging 5 people in 7 chairs is 7p5. So we have addressed this question in one of the previous lectures. Now we can generalize this formula. So the generalization is like this. The number of injections from a set A with m elements to a set B with n elements is going to be npm, as long as m is less than or equal to n. If m is greater than n, the number of injections is going to be 0. So if m is greater than n, that means if the number of elements in domain is greater than the number of elements in codomain. Suppose we have A, B, C here, and here we have only 1 and 2. We cannot have any injection. So the condition must be the number of elements in the domain must be less than or equal to the number of elements in codomain. If the number of elements in domain is greater than the number of elements in codomain, we cannot have any injection. Now this is our last example problem. Find the number of ways in which 4 letters can be placed in 4 addressed envelopes so that no letter goes into the envelope meant for it. Let me explain the question for you. There are 4 letters L1, L2, L3 and L4. And we have 4 envelopes, addressed envelopes, in the sense L1 should be posted, L1 should be placed in E1, L2 should be placed in E2, L3 should be placed in E3 and L4 should be placed in E4. So this is the actual arrangement. But now they are asking us to find out in how many ways I can place these letters in these envelopes so that no letter goes to the envelope meant for it. That means L1 should not go to E1, L2 should not go to E2, L3 should not go to E3 and L4 should not go to E4. So these kind of problems are called derangement problems. And we have a formula for this one. So we can give the proof for this formula in the last class. So if you know principle of inclusion and exclusion, we can give the proof for this formula. Anyway, the proof for this formula is not given in the textbook. So you have to understand the definition of derangement problem. So this is the definition. Suppose there are n people in the row. So we are reshuffling these n people, and in how many arrangements no person occupies his or her original place is called as the derangement. Suppose there are 10 people sitting in a row. Now I have rearranged these 10 people. I want to find out how many arrangements are there such that no person occupies his or her original place. So and the answer is going to be like this. If there are n people, the answer is like this: n factorial times 1 upon 2 factorial minus 1 upon 3 factorial plus 1 upon 4 factorial minus 1 upon 5 factorial and so on up to minus 1 whole to the power of n times 1 upon n factorial. So we can use this formula here. Here n is equal to 4. The formula for derangement is n factorial times 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial and so on minus 1 whole to the power of n times 1 upon n factorial. So here n is equal to 4. So this implies 4 factorial times 1 upon 2 factorial minus 1 upon 3 factorial plus 1 upon 4 factorial. So which is equal to 24 times 1 by 2 or minus 1 by 6 plus 1 by 24, which is equal to 12 minus 4 plus 1, which is equal to 9. So there are 9 ways in which we can arrange these letters in these envelopes so that no letter enters into the envelope meant for it. I repeat, there are 9 ways in which these letters can be placed in envelopes so that no letter goes into the envelope meant for it. So we are basically using this formula and this formula is meant for derangements, and the definition of derangement is like this. So after rearrangement, no person or no object will occupy its original place. If no object occupies its original place, then it is going to be called as the derangement. And the formula for derangement is like this: n factorial times 1 upon 2 factorial minus 1 upon 3 factorial plus 1 upon 4 factorial, and so on up to minus 1 whole to the power of n times 1 upon n factorial. So with this we have completed all the example problems. You have to do all the exercise problems on your own. I repeat, you have to do all the exercise problems on your own.